First lesson that we're going to try out today. While you guys are watching this PowerPoint presentation, please remember that this is the lecture portion. So as we're moving through, it's really important that you pay attention. If you have questions about what you're hearing or what you're seeing, write down questions. You can ask them tomorrow in class or email me and I'd be happy to answer them. But let me set up some ground rules and expectations for what I want to happen while you're watching this video. One, I want you to listen to it and watch it and see what's happening. Two, I do want you to take some notes. I think that that's going to be beneficial. And three, during this presentation, there's some interactivity where I'm going to ask you guys to pause the video and practice your skills. It would really be good if you did that and could show evidence of that tomorrow in class. And you can do all of this in your lab notebook. Once again, like I said, if you have any questions, just email me. But I thought it might be fun to watch the presentation this way. So today we're going to learn about chemical reactions and chemical reactions. So let's move on. So what's the big idea? And biology, it's about life. It's a study of life. And to understand life, you have to understand chemical reactions. They're the fundamental part of life that you just have to understand. And we have to understand how these chemical reactions relate to two big ideas, matter and energy. And today, during this presentation, we're going to be focusing on matter and why that's important. So throughout this entire presentation, we're going to talk about matter. So let's talk about chemical reactions real quickly again. I know we just did some review, but first of all, chemical reactions are always written as chemical equations. And as we've learned before, here on the left-hand side, we have the reactants, and on the right-hand side, we have the products. And this little arrow right here is the yields arrow. And that just means that the reactants yield or change into the products. And you guys know this. We looked at this with enzymes, but this just serves as kind of a quick review of what chemical reactions are. So let's take a second and talk about the conservation of matter. First of all, what is matter? And something that's really important for you to understand is the difference between an atom and a molecule or compound. And this is a somewhat confusing topic, even though some of you learned about it last year. An atom is the smallest unit okay? It has protons and neutrons, and you guys have talked about this. Atoms are the smallest chemical units, okay? And a molecule or a compound is multiple of these atoms put together to make a compound. So let's talk about an atom that we have a lot of experience with, carbon. So that is a carbon atom, one carbon atom, and if we wanted to make that into a molecule or a compound, we would combine it with another atom. Or it could be like that. So an atom is one single smallest unit, and the molecule is multiple of these atoms. And so what does all this mean? These are concepts about matter. And one thing you need to know is that matter cannot be created and it cannot be destroyed. In fact, all of the matter that's ever existed, ever, still exists today. So it just keeps getting transformed, recycled, and things like that. So that's a super important concept that you need to make sure you understand. So let's go back though, because I'm a little confused. I thought we were talking about chemical reactions. So how does the conservation of matter actually relate to this idea of chemical reactions? And first, what I want to say is that the number of atoms, which we've learned is the smallest unit, right? So the number of atoms on the reactant side must equal the number of atoms in the product. Very simple. So let's walk through this together. So let's split this in half. This side, like it says, we have our reactants. So we're going to deal with those first. So first, I'm going to look for all the carbon atoms. So here's carbon. We're going to identify them. Here's carbon, and it says I have 3 carbons. So I'm going to take that 3 and put it into the number of atoms because I have 3 carbon atoms. Next, I have hydrogen, and I have 8 hydrogen atoms here. Do I have any other hydrogen atoms on this side of the chemical reaction? I do not. So that 8 comes down here into the number of atoms. And lastly, we see something a little different. This number out in front, this 5, that's called a coefficient. And when you see a coefficient, you multiply that number by the subscript. So 5 times 2, everybody at home say it with me, is 10. So 10 is the number that goes here. So without even looking at the product side, if we know that the number of atoms of each element has to be the same on the reactants and the product side, what would we predict would be the number of carbons on the product side? 3, right? Look, there's 3 right there, so we predict 3. How many hydrogen? 8. How many oxygen? 10. Perfect. Let's add these up. So 10 plus 8 is 18. Plus 3 is 21. So we have 21 total atoms on that side. So now let's move over to our reactants side. To our product side. And we are going to start this process over again. We are going to look and see what's going on. So first we're going to do carbon. So here's that coefficient. And whenever there's nothing behind, there's not a subscript, you can just say it's 1. So 3 times 1 is 3. And that's here. And then for hydrogen, we have it here, and we have 4 times 2, which is 8, so it goes here. And then for our oxygen, we have 3 times 2, which is 6. There's the answer. So we have 6. And then we also have oxygen over here, and we have 4 times 1, which is 4. So 6 plus 4 equals 10, which is what I have here. So let's add these up. How many total do I have? 21. Look at that. Those are equal. Carbons are equal. Hydrogens are equal. Oxygens are equal. And if you can read anything that's on this page now, good for you, because I don't even know what it says anymore. So let's move on to our next slide. Here we go. All right, this is a practice. So what I want you guys to do is pause this video until you've done this at home. And I'm going to quickly run through it and not explain it. If you need a new explanation, go back and watch the last part. But please pause the video because I'm going to do it now, and I want you guys to have practice. So welcome back. You should have gotten 4 hydrogens and 2 oxygens on each side, which is 6 atoms on each side of the equation. Now we're going to move on to photosynthesis, and we want to find out how to balance this. So I want you guys at home to go ahead and take some time and balance this equation. So I'm actually not going to tell you the answer to this one because I hope that the next couple of slides will help reveal some information to you. So here we're going to move on. If you don't believe me that matter is conserved, let's take this example. So here, my screen recording thing is covering it up, I think, on your view. But the black balls are the oxygen. These white little half semicircles are hydrogens. And then these red spheres are the oxygen. And we're going to see what happens when we do this chemical equation. So you can see on the left-hand side of this equation, we have 6 waters and 6 carbon dioxides, which is what you should have gotten. There should have been 6s in front of those numbers. So we You can count them up if you don't believe me, but I promise you all the number of atoms on the left-hand side will equal the number on the right-hand side. And as you can see, these are physical representations of what's happening. So this is saying that these 6 waters, so these are H2Os, plus these 6 carbon dioxides yield or turn into this one sugar, which is this right here, and this is called glucose, and that's our one giant sugar, plus 6 oxygens, which are these guys. Go through, count if you don't believe me, promise you it's going to work out. So let's go back real quickly to this part, which I said I wasn't going to tell you the answer to, and let's write in the answers that we just proved to ourselves. So 6, 6, there's a 1 there and a 6 there. And then you guys should go through and make sure that all of these numbers match, because they will. Pretty magical things. All right, let's go back down. Let's make sure that we are going back down. Sorry, guys at home. It's a little... Okay, here we go. Keep going. You can do it. Oh, apparently we can't. All right, hold on. As always, you know, here in biology, we have technical difficulties almost every day. And it's not different when you're not here. There's still difficulties. So let's talk real quickly about synthesis reactions. Synthesis reactions are when things come together. You can notice here that these smaller atoms, I'm sorry, I just misused a word. Geez, Miss Matson. These smaller compounds or molecules are being converted to a larger molecule. That is called synthesis. All right? Thus the term photosynthesis. Now, for those of you at home, which is everyone hopefully, what is sunlight in this equation? Well, I said before that sunlight would go above just like our enzymes did. And it goes above because it provides energy for this reaction and allows photosynthesis, which happens in plants, to occur. So, decomposition reactions. This is just the opposite reaction, but here you'll notice that we, instead of going from smaller molecules to larger molecules, we're going from larger molecules to smaller ones. Pretty cool. We'll talk more about decomposition reactions tomorrow. All right. So what I want you guys to do for your little homework is I want you to go through this PowerPoint slide. You can go ahead and pause it if you need to. Go through this one as well, and also indicate whether it's synthesis or decomposition. And then also this one. So you're going to have 3 problems where you're putting it all together. So that is your homework. Please do it in your science notebook. And tomorrow, I know, Miss Matson, you say that this is going to happen. You say that matter can't be created or destroyed. I don't believe you. It's okay, guys. I wouldn't believe me either. I'm tired. I've had a long day. I could be completely lying to you. So tomorrow we're going to do a little demo to see if I'm right, to see if what I'm telling you is actually true. So I want to know what happens to the mass of radishes as they grow. So here, I'm going to write in pink now because I'm getting tired. Here we have our radish seeds. So if we use a certain mass of radish seeds, what will happen to the mass as they germinate or begin to grow? And then as they turn into radishes? We want to know these answers to these big questions. So what I want you guys to do is write down what you think will happen to the mass of the radish plants as it grows. Will it increase, decrease, or remain the same? And I want you guys to give me a short explanation of why you think this. All right, so what do I expect for tomorrow? I expect you to come in with this information, understanding it, having questions, ready to participate in class, and I want you to have those 3 practice problems that have been presented in this PowerPoint And I also want you to come ready to discuss what you think will happen to the mass of a radish plant as it grows. Alrighty, guys, thank you so much. Email me if you have questions. Now, I need to go because I am late for an eye doctor appointment. Have a wonderful day. I'll talk to you guys tomorrow.